Let's go over programming exercise number 31, which involves cryptography. This will be encoding and decoding a text file. This is the written description of the programming exercise. It asks you to write a C++ program that will accept a text message from a disk file and produce a coded or decoded message. If the text file is already readable, then you want to code it into a coded message, and if it is unreadable, then you want to decode it into something that is readable. The code is a letter substitution cipher. The letters in the text message are identified by their numerical position in the alphabet. A corresponds to letter number 0, B is letter number 1, Z is letter number 25. The code number, or this is the number of the encoded letter, is calculated using this kind of formula. The code number is equal to a constant A plus a constant B times the letter number. A is an offset value, and B gives the spacing between the letters. The code number is also to wrap around so that the values of the code numbers range between 0 and 25. The offset value is an integer that can range from 1 to 25. An offset value of 26 is not as helpful. That's no code at all, practically. And the spacing value is an odd integer, not greater than 11. So this gives the program a fixed number of codes that can be applied. And the values in this calculation are to be based upon the number of characters in the message, including all of the spaces and the punctuation and the other characters. And I've given you a formula to use the number of characters in the message. That's the value of L. And if you apply these equations, you will, based on the value of L, you will return an offset value between 1 and 25, and this spacing value that is a positive odd value no greater than 11. We want to put the code into effect by creating a lookup table as an array. The same lookup table is used in decoding the messages. Also want to revise the text so that it contains all lowercase letters. This will make coding and decoding a bit simpler. So we are applying the code only to lowercase letters, and let's leave the spaces and the punctuation unchanged in the coded message. So you need to write the program to allow the user to choose either to encode a message, encode a regular message, that's misspelled, encode regular messages, and to decode coded messages, write the encoded and decoded messages to text files. So the program will receive in a text file from the hard drive. It will apply the code or apply the decoding algorithm, and then produce and then write the resulting file back to the text, back to the disk drive. So as usual, document the program with a written description of the program and the structure of the program, a flowchart to graphically illustrate the structure of the program, and the code listing. Now put those three items into a Word document, and also want to include in the documentation the text files of your example input message and the corresponding coded message. And you will also find two coded message files that I want you to decode and determine the secret message that I have for you all. Okay, so that is the written description of programming exercise number 31. Okay, programming exercise number 31 involving cryptography. At the top of the code listing, as usual, you need the header files, the libraries containing functions that we will need to use in the program. I think for this program we need the input-output stream library for functions, for keyboard input and display output. We also need the string library for functions to manipulate strings, and the fstream library for file input and output. And as always, we're using the namespace standard. So when you create your project, it will create a folder to put your C++ files into. You need to then drag and drop in this case, you could even create an input text file. In this case, I've given it the name file in.txt. You can give your file the name you wish, as long as you include that name into the code listing and you're consistent. You can use Notepad to create your own text file. So whatever you want to use to test your program is perfectly fine, but this is the kind of text file you might want to create. It's probably good to have all of the letters so you can verify that they're all being encoded correctly. I also threw in some punctuation and spaces, and also a few uppercase letters because we want to write the program to convert those uppercase letters into lowercase letters as well. So this kind of text can be used first of all to declare an object in the class string. This will be the variable name that will hold our text message. Our text message will be one line of text. If we wanted to encode messages with more than one line of text that included line returns, that would be a bit more complicated. So let's simplify it a bit and have our message be one line of text. The string library has functions that will create objects of this class, and we can then store our line of text into this variable name. I chose the variable name message. You can choose whatever variable name you wish. The next line declares an input file stream with the ifstream command. Again, this is from the fstream library. The letters FIN are the name I use to denote a file input. You can use letters, a name that you wish, but you'll need to be consistent with it. And inside the parentheses are the parameters. First is the name of the input text file. C is the disk drive letter, and then the name of the file in the .txt extension, all in quotation marks. This matches the file name that is in the folder with the C++ files. And then finally we're setting the input-output stream for input. The third line is the getLine function. This is one of the functions available with the fstream library, and we're going to get an entire line of text, so it will read in text from the beginning of the file till it reaches a end of line character, a paragraph character. And so it's going to read from the fn, or the file in stream, which was defined in the line above, and it's going to take in that line of text and assign that text to the variable name message. after the message is read into the program, the input file is then closed. You can easily display the message on the monitor simply by the C out and then directing the message to the console output, followed by an end line, and you can easily display the text on a monitor. When I do this, this is what I find. It opened up my text file that I showed you previously, read that one line of text into the program, assigned it to the variable name message, and when I display message on the monitor, it displays exactly the text that was in the text file. This bit of code, first in the first line, it has a function call to return the number of characters in the message. So I declare an integer L for length, and I assign that the result of this function call. Message is the name of my string object, and the dot length function will return the number of characters in the message, including spaces and punctuation, everything from the beginning of the file to the first end of line character. So that gives me the number of characters that are in the message, and then following that are the calculations for the offset value and also for the spacing value for the coded letters. When this is run in the program, it determines there are 36 characters in my message, my test message. The offset value is 12 and the spacing value is 1. That's just those are the numbers you get with a message that is 36 characters long. If you have a message with fewer or greater number of characters, you will get different values for A and B. So 12 is the offset value, 1 is the spacing value. Here is the table of the ASCII code numbers for the characters on a keyboard, and this pretty much includes all of the characters that could be on a keyboard, including number 32 is the space, 33 is the exclamation point, and then you have other punctuation. The ones we're really interested in start with ASCII code number 65, which is an uppercase A, and then the letters of the alphabet run in alphabetical order down to uppercase Z, which is ASCII number 90. A few more punctuation marks, and then it starts over with the lowercase letters, ASCII number 97 for a lowercase a, all the way up to ASCII number 122 for a lowercase z. Now it's interesting to see that if you want to convert a number from uppercase to lowercase, all you have to do is add the value 32 to its ASCII code number, and that will result in a lowercase letter, and that applies no matter which letter of the alphabet you're looking at. So we want to apply our code program to the lowercase letters, which are ASCII values 97 for a lowercase a all the way through 122 for a lowercase z. This section of code simply prints out each of the characters in the message string. The first, it sets up a for loop. We are treating our message string simply as an array. So we set up a for loop, declaring an integer for the loop variable that's n, starts at a value of 0. It will run for all values from 0, and then n less than the number of characters in the string. In our case, L is equal to 36, so we will go characters 0 to 35. That's a total of 36 characters. And then it increments n. And inside this loop, we print out a little bit of text and then print out the index number for the string array. That then is followed by the character in the string array, and we're treating our message string is simply treated as an array, so we can access each individual character in this message string by using the index number n, and then it prints out the letter, the number of that, the ASCII number for that character. The int operator used as a function will take the ASCII character in the message, and this will return its ASCII code number in decimal. So I ran the program, and this is what I find. My message is 36 characters long, and you can see I'm looping through each individual character in that string of characters, starting with index number 0, which is an uppercase A, and ASCII code number 65. That's followed by character 1, or index number 1. That's a lowercase b, ASCII code number 98, and runs all the way down to number 35, which is the last character in the message, which happens to be an exclamation point, ASCII code number 33. The spaces are simply characters as well. The space appears to be character number 32, and the question marks and the other punctuations are characters. The question mark is ASCII number 36. This this bit of code is intended to convert the uppercase letters into the proper lowercase letters. And again, we are looping through this message string as an array. So I set up the loop again with an n as the index number in the loop from 0 to L minus 1. And then there is an if statement that checks to see if this character is an uppercase character or not. And I know it's an uppercase character if its number falls between 65 and 90. If it's greater than or equal to 65 and less than or equal to 90, it's an uppercase A through uppercase Z. So we have an if statement to determine if the character is an uppercase character. And if it is an uppercase character, we simply add 32 to the character, and that will convert it to a lowercase character. So we would take, for whatever value of n we are looking at, let me see if I can get the laser pointer. So for whatever value of n we are looking at, if that is an uppercase character, we will take the that character and add 32. What C++ does when you take a character and you add an integer, it adds that integer to the ASCII code value for that character. So if it's an uppercase A, which I believe is 65 in code number, then it will add 32 to 65, which will give you a 97, which is the code value for a lowercase a. So this will evaluate to a lowercase a and assign that to that character's location in the message. Okay, so this is intended to convert all of the characters to lowercase values. And sure enough, after I print out the message again, you can see that there are no more uppercase characters. They are all lowercase characters. It made no changes at all to the spaces or the punctuation, and made no changes at all to the characters that were already lowercase. So let's see, this is the code that generates the lookup table for our code cipher. So I first declare an integer array for the code lookup table. It's an integer array with 26 elements, one for each letter of the alphabet. The for loop simply loops through all 26 elements in this array, one for each letter number from 0 to 25. And then we have the equation that calculates the corresponding code letter number. So again, A and B are parameters that are based upon the number of characters in our code message. For each value of n, so that this is for each letter number, we calculate with this calculation a corresponding code number, and we get it to wrap around between 0 and 25 by doing a modulo divide by 26. So the result of this will be the code value for each letter value, and it will range from 0 to 25. And the next bit of code simply prints out, is a for loop to print out that, that lookup table, to display that on the monitor. And when I operate that part of the code, this is what it generates. Using the value of A and B that were determined by the number of letters in our message, it then generates this code lookup table, and it's an array. The array name is code, and the elements run from element number 0 to element number 25. Code 0 corresponds to the letter A, and this is telling me that our substitution will be for every occurrence of the lowercase a in our input file, it will be replaced by letter number 12 in the alphabet. Now, I don't know what letter number 12 in the alphabet is offhand. You can count it up yourself to see. And code letter B, which is code letter number 1, will be replaced with letter number 13. So 12 is the offset value. Letter 0 is replaced by a letter 12, and we have a code spacing, letter spacing of 1. Now, depending upon the number of characters in your message, these values will be different, and you will get a different code applied to the message. Okay. Okay, this is the section of code where the code is applied to our message string. Again, we're setting up a loop to loop through the message, the characters in the message array. The first thing we want to do is to check to see that it is actually a lowercase letter, and it will be a lowercase letter if the value of the character that is returned by message with index number n is greater than or equal to 97 and also less than or equal to 122. If those two conditions are met, then this is in fact a lowercase letter, and then the algorithm for applying the code will be placed where these 3 dots are. So you apply the code lookup table there. Now, in applying the code lookup table, this is the kind of thinking I went through, and there may be some other variations, and you might be able to think of something better, but this is it's a bit brute force, but it does the job, it appears. So n is the index number of the loop, or it's the loop variable, and as n goes from 0 to L minus 1, we will look at each character in the string array. Now that will be a character, A through Z. If we apply the int function, that will return its ASCII code value in decimal. That will range from 97 to 122. Before we can apply our code formula, though, or apply our lookup table, we need to shift from 97 to 122 down to 0 to 25, and we can simply do that by subtracting the value 97. Okay, so this will now will result in a number between 0 and 25. Again, for each character in our message string, we will determine its letter value, and once you determine its letter value, you then can apply the lookup table to find the letter value of its coded form. So in this case, with this example, if the letter value happens to be 8, then that letter will be replaced by letter number 20. Now, I don't know offhand what letter number 8 and letter number 20 are in the English alphabet. You can count them out on your own fingers if you want to know. So we take the number. This operation has returned a number for the character that is from 0 to 25. We can use that number inside the code array. So we're looking at the code array at index number that corresponds to the letter number in our original message. And that will return the coded letter value, again, between 0 and 25. So this value will be the coded letter value. Then, before we can change this into an actual character, we have to again add 97 so that it will range between 97 and 122. And taking the ASCII value for the coded letter and using CHAR, the character keyword, as a function, turn that integer number that lies between 97 and 122 into its corresponding code character. And then this code character can be assigned to the proper place in the coded message string. After we have finished the coding process, we want to write the coded message out to the text file. To accomplish this, we first declare an output file stream. Fout is the name I used to reference the output file, and it is located on the C drive, and I gave it a name to indicate that this was the encoded text result of my coding operation, and I set the input-output stream for output. And again, the file will be located in the same folder as the C++ files. If it does not exist, it will be created, and if it does exist, it will be overwritten with new text. And then we simply have a for loop to loop through each character in the now encoded message, and then write those characters one at a time to the output file. And after it has written all of the characters to the output file one at a time, the file is then closed, and the result is shown at the bottom of the screen. That is the coded text file, and you can see that it's got a particular offset value, so what was previously an A is now encoded as M, and what was previously a B is encoded as N, and I kept things in order so you can see how they all fall. The punctuations and the spaces are included as they were in the original document. Now, if you want a more complicated code, you could do something else with spaces and punctuation, and that would make it more difficult to decode if you didn't know the program and the key to the decoding, and that would be a better code. But we'll leave that for another day. We're working with a simple code for the moment. So now let's think about the decoding algorithm. What we have is this string of characters, and I know by the number of characters in this line of text, I can find the lookup table for the decoding. So what I need to do, if I were to decode this, I need to determine the code number for the letter M. What is the code number for the letter M? A, B, C, D, E, F, G, H, I, J, K, L, M. That would be number 12, I believe. And that makes sense. Our offset value is 12. So M is the number 12. So for decoding, I've got to search down this list until I find the number 12, what it happens to be up here at the top, of course. And I'm working back the other direction. So for decoding, I will replace letter number 12 with letter number 0. So our algorithm has to search down the lookup table until it finds the number that matches the decoded letter. So let's say we're trying to find the match for number 22. I don't know what number 22 is offhand. You can count it out on your own fingers. And once I've made that match, I know that the decoded letter has letter value 10. And this is what we need to do in order to decode a message. Here is a bit of code that is intended to do just that. Again, loop through the coded string, message string, setting up a for loop. N is the index number for the for loop. It's also the index number for the coded message string array. And then you have to determine if the character is a lowercase letter. Using the same criteria as we did before, it has to fall greater than or equal to 97 to a greater than or less than or equal to 122. And if you determine that you are looking at a lowercase letter, you then have to search through the lookup table to find where the character in question matches the character in the lookup table. So to do this search, I found it works this way. You might find a way that is better or quicker or more intuitive to you, but this seemed to work for me. I initialized a counter M, set it equal to 0, and then did a while loop. I'm looking at character number N in the coded message. So I take that character, turn it into an integer, and then subtract 97. So this will take the character number and shift it down so it falls between 0 and 25. And then I want to compare with code letter M. So M is based on this counter that I just set up. So it starts at code 0, and it's comparing that to the number in the message. And if they are not equal to each other, then I want to increment the counter and check the message character against the next entry in the code table. And if they do not match, again, increment the counter number and keep this up until I find the code entry that matches my coded message entry. So continue the search until the coded message number matches the lookup table number. And when that occurs, then it'll go back to this while loop, and these will be exactly equal to each other, and that will return a false. And in that case, it will not increment the value of M. It will go down here, and what I'm taking is the coded or the code number M, that is the decoded letter number, adding 97 to put it in the proper range for ASCII, and then turning that into a character and assigning that back to the message string at the appropriate spot. Okay, that's a little bit around about, but think about it, and I found this to work. Increment the counter number and compare the next coded character number. When the coded character number matches, stop searching and use the counter number to get the decoded character. Okay, and that is the explanation for this programming project. Okay, I've shown you code to complete the major tasks in this programming exercise. I haven't covered all of the tasks. There are still a few things you'll probably need to straighten out, but I don't think I think they're well within your capabilities. And again, I've included two coded messages in the form of text files that you can decode and find the secret message. Thank you very much.